Let's begin. Today's May 21st, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So here are our 5 criteria cards, numbered 6, 11, 16, 19, and 21, and we're using the purple verification cards. And above you got the unique identifying number for this puzzle that you can always go and look up on turingmachine.info. Let's go solve. So in our grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And on the bottom row, we've got criteria card D and criteria card E. Criteria card A will look at the middle digit, the square digit, and will let us know whether that value should be an even or an odd digit. Criteria card B will look at the first 2 numbers, the triangle and the square, and we'll be comparing them. Should the triangle value be less than the square? Should they be equal? Or should triangle be greater than square? Criteria card C looks at the whole 3 digits and will let us know whether there should be more even than odd digits, or alternatively, less even than odd digits. Criteria card D will look at the first 2 digits, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will take again look at the 3 digits and will let us know whether there should be a pair of digits, repeating digits, as in the example 131, or alternatively, either there is no pair, in which case it'll all be different digits, as in the example 134, or possibly a single digit repeated 3 times. So again, our objective is to find this one unique 3-digit code that will meet all of the following criteria. And we're going to start off with a proposal of 314. So I'm going to start by testing criteria card A and finding out if that middle digit is odd or even. Okay, so the Turing machine approves of my proposal. So again, if I look at my 3-digit code, that middle digit is odd, the Turing machine approves it. So that means that we know definitively that square is an odd digit. So I'm going to come and write down in my notes in section A that square is an odd digit, and I'm going to come up and eliminate all the even digits since they are no longer valid. Now, the Turing machine just tells me that it's an odd. I don't know if it's a 1. It could be a 1, it could be a 3, or it could be a 5. All I know is that it's definitively an odd. All right, next, I think I will test criteria card E and find out if there are a pair of digits or not. So criteria card E, let's see what the Turing machine says. And it also approves. So notice again, my initial proposal of 314 uses all unique digits, so that means that there is no pair. So let me go ahead and write that down for criteria card E, that there are no pair of digits. So again, the possibilities are that that our solution is going to have all unique digits, or that there's going to be a single digit repeated 3 times. Okay, so at this point, I really can't eliminate any numbers just based on that. There's just still too wide of a selection. Okay, so well, now that I know that there are no pair of digits and I know there's an odd, let's test criteria card C. Okay, so in this case, the Turing machine does not approve. Notice that I have, in my proposal of 314, I've got 2 odds to 1 even. It does not agree with that. So that means that there has to be more even than odds. So in my notes for criteria card C, my note area, I'm going to write down that even is greater than odd. Okay, well, let's take a look at that then. Notice that, remember, we don't have a pair of digits. And the fact that there are now more even than odds, we know definitively that it can't be a single digit repeated, right? I've got one odd in the middle, and then I need to have at least two evens. So that means that triangle and circle are even. So we know that there's no pair of digits, but then all digits are unique. Okay, so what I'm going to put down for C, not only are there more even than odds, I'm going to say basically that triangle and circle are even. So triangle and circle and circle are even. Okay, so that was a great combination of three cards to help us really sort of get a good feel for what the structure of the solution is going to be. So I'm going to come up to my triangle and I'm going to eliminate all of the odds. And we'll do the same for my circle. And in addition, let's see, there is actually another little positive wrinkle. So not only do we know it's going to be even, odd, even, but really because the digits are unique, that means that it has to be a 2-4 combination. You can't have a pair, so you can't have 2-2 or 4-4 in triangle and circle. So I'm going to say 2 and 4. I'll do it this way: 2, 4, and an odd. Okay. So, well, I think this was a fantastic round. Again, it kind of gave us an idea of what it's going to look like. We did use up our 3 maximum tests per proposal or per round. So now I've got to construct my second proposal and think of what did we not test. We did not test B, comparing the triangle and square, and we did not do D, the sum. Okay, so let's start off with talking about the sum. Since we know that triangle is even and square is odd, we can conclusively discount the possibility that it's equal to 6. Since an even plus an odd will be an odd, can't be 6. So it's either going to be less than or greater than. And that'll basically let us know, in part, possibly which of the 2 evens it's going to be, and force a circle to have the other one. Notice that, again, if you look at the 5 criteria cards, there's really no mention of circle, only square and triangle. So it's in combination with all the clues together that'll force the circle even digit to be the opposite of what triangle is. So let's take a look. The field is open. It could be less than there. 3? I think there may be 3 possibilities each. 2 plus 1 is 3. 2 plus 3 is 5, and 4 plus 1 is 5. All those are the cases where the sum is less than 6. But then you also have the potential 2 and 5 to give you 7, 4 and 3 to give you 7, and 4 and 5 to give you 9. So it's really a 50-50 as to what the sum is going to be, whether it's less than 6 or greater than 6. And then, well, let's take a look, because I think criteria card B may help us. We know also, since it's even and odd, it can't be equal. It just can't be equal. So this will also help us to figure out that combination. So Let's see, is there a way where we could do it with a minimal amount of tests in the second round? So if triangle is bigger than square, if triangle is bigger than square, that means it wouldn't be a 5, but it still could be a 7 or something greater than. And I think similarly, you could say that if square is less than, if triangle is less than square, that means that square cannot be a 1, and then maybe that would force it to be, well, that is interesting. If triangle is less than square, there's only one sum that's less than 6, and that would be 5. Let me go back here. What if it's the opposite, where triangle is bigger, so it wouldn't be 5, and you would also get that. That's an interesting, both of them sort of point to 4, 3 here as a potential. But again, I think it's a 50-50. Is there a way where we can kind of hedge our bets? I'm gonna do where the sum is greater than. Let's see, is it possible to have 4, 3? Well, 4, 3, 2 would be the only possibility. Yeah, so basically it's going to be a middle digit that's odd, and then, the triangle circle are just going to flip the 2 and 4s. Yeah, so let's just go with 4, 3, 2. Let's just test that out. I don't think there's anything to be gained by overanalyzing. So let's do 4, 3, 2. All right, so let's do the sum first, which is criteria card D, and let's see what happens. Okay, so it did not approve of my sum being greater than. So I know that for criteria card D, then we know that triangle plus square must be less than 6. Okay, so what can we say about that? Well, that means square cannot be a 5, because 5 plus 2 and 5 plus 4 will always be greater than. So I know that square cannot be a 5. And so I believe there are 4 is still okay, because you can add it to 1, and then 2 and 1 and 2 and 3 are all less than. Okay, so we could just eliminate that. Now let's take a look at criteria card B and see, is there anything that we can conclude without actually playing it? So can we say, yeah, we can still say there is one possibility where triangle is smaller than square, triangle is smaller than square, that's 2, 3. But if it was the other way around, where triangle had to be greater than, then we would know it's 4. I think we'll just play it. I don't think I can conclusively deduce it. So let's just play criteria card B and see. That is also incorrect. So notice that triangle cannot be greater than square. It should be, and we already said that it can be equal. So that means that triangle should be less than circle. So I'm going to say triangle for criteria card B. Triangle must be, I'm sorry, if I said circle, I apologize, I meant square. Triangle should be less than square. Okay, so let's see, can we eliminate anything if triangle has to be less than? So I don't think it can be 4, because 4 is bigger. So there you go. So I think that'll, excuse me, that'll already establish our solution. So that means that Well, let's see. Well, we do know that it's going to be 2 blank 4. Ooh. Well, this is interesting. I still have 2 possibilities, 2, 1, and 3. How is that? Okay, okay. Oh, okay, my bad. I guess I did not realize that, yeah, square cannot be a 1, right? 2 is not less than 1. So, yeah, it forces the square to be 3. Okay. I'm not sure when exactly I missed that, but yeah, that's what it is. So it's going to be 2, 3, 4. So let me cross out the 2 there. And so my solution should be 2, 3, 4. And so let's kind of review before we go to turingmachine.info and verifying it officially. So is the square an odd digit? It sure is. Is the first digit smaller than second? Yep, 2 is less than 3. Do we have more evens than odds? Yeah, we got a 2 and 4. And of course, since we know the middle digit is odd, the first and last are even. Yep. And because they are unique, you have to have only a 2 and 4, no pair. Yep, that's correct. And is the sum less than 6? Yeah, 2 plus 3 is less than 6. So it looks like we got a winner. So let's actually go to turingmachine.info and verify. So we're going to test our code, and it was 2, 3, 4. Verify. All right, fantastic, as anticipated. But as I've always stated, the true test is, did we do it efficiently? Did we beat the Turing machine? So let's actually go do that. And let's remember we did A, C, E, and those 2 were correct, or A and E were correct, and C was incorrect. And then we did the remaining B and D. So A, C, E first. A, C, E, and we did B and D, and those were also incorrect. And let's see. All right, fantastic. So we beat the Turing machine in by 1 question. We both did it in 2 rounds. We just did it slightly more efficient. So it was a great win. And I did just want to come back and just say, out of the 5, we got 3 incorrect. So just because you get some X's does not mean that you're doing anything wrong. As long as you're not committing the same mistake twice, X's are basically eliminating bad choices or bad selections. So as long as you're not committing the same mistake twice, it's okay. So this was a great puzzle. I really enjoyed it. I hope you did too. If you did, please do give it a thumbs up. Leave a comment. See what you think. Did you catch me making a mistake? I might have. But please do leave a comment. And if you don't want to miss any future videos, please hit subscribe to be notified for the next one. Well, until next time, have a great one.